In this video, we're going to look at designing and structuring an Excel spreadsheet. We're not going to give you hard and fast rules. Design and structure will depend on the context you work in. Workbooks for financial models will likely differ in their requirements from structural engineering workbooks. Accountants will have different priorities and conventions from data analysts. The design and structure of your worksheet will also likely change based on whether it is a quick and dirty solution for your eyes only, or whether it is designed to be used by a whole team of people. So before you start, always take a moment to consider your business environment carefully. What do you need to achieve with your spreadsheet? And who is going to be using it? The more advanced you become in using Excel, the more you will realize that the rulebook becomes less reliable and that you have to increasingly rely on your judgment and experience. But in general, there are some principles that should always guide your decision-making. First and foremost, our workbooks must be accurate. That means validating data entry where possible, using robust formulas, and making sure that those formulas are both correct and auditable. We also need to aim for flexibility. A flexible workbook will respond well to change, and it's a good idea to always design with change in mind. By avoiding hard-coded values and formulas, for example, and dual entry of the same data, we can ensure that our workbooks remain flexible despite future changes. Closely related to this is that our spreadsheets need to be responsive. In other words, if we add a new value to a lookup list, we want that to automatically appear in our drop-down lists. If we add new data, we want that to automatically be picked up by any of our calculations. So this ties in with flexibility, but it's also about the workbook responding to user changes. Our workbooks should be easy to maintain. A good rule of thumb is to keep it simple. Macros, for example, can be a great and tempting solution, but are often hard to maintain, especially if the original programmer has moved on to a new job. So try and explore the simplest path to a solution for your problem first. Make sure the formulas are transparent so they can be understood by others, and document the assumptions you use in your design and calculations for yourself and others. And finally, your spreadsheet must be user-friendly. Think about who is going to use the workbook after you've created it, and don't forget that this includes your future self as one of those users 6 months down the track. Okay, let's take a look at this week's case. Alex is going to be designing a workbook to produce a sales report for a real estate agent in Melbourne. The first thing he needs to do is think about how he's going to structure and lay out his workbook. This exercise is sometimes referred to as wireframing and can be done on pen and paper. So before you get started, perhaps take a moment to sketch out what your inputs are going to be, what kind of calculations are you going to do, and consider any assumptions you make and what the output will look like. The sales report will be based on sales data that is manually entered into Excel. Several people will work on this file down the track, so user-friendliness is a key consideration. We will also create calculations to generate the summaries we need for the report. There is a temptation to put it all into one sheet, but this is generally not a good idea. Keep your raw data separate. This ensures that your original input stays intact and you don't end up damaging it, which can easily happen. In all but the simplest workbooks, it's really a good idea to achieve that degree of separation between your data, that is your input, your calculations, and your output in your presentation. So coming across to the left here, we have our raw data. A little bit later this week, we will talk about how we can ensure that our spreadsheets are self-documented. And labeling everything is one of those steps we need to take. So label your tabs. It's important to use a simple and meaningful description. In our case, we will name the sheet Data. We often see spreadsheets where the data starts in cell A1. Consider leaving at least 2 or 3 rows at the top to later on place advanced filters, summary calculations, or even something as simple as a heading. For now, we're going to enter a heading in here, which is Melbourne Sales. It's important to keep related data in a continuous table. If we fail to set up our spreadsheets like that, It can become impossible to use powerful features like pivot tables and the subtotaling feature. So let's take a closer look at the data we have here already. We want to make sure that every column has a sensible and unique heading. Again, these heading names should be descriptive and meaningful. We also want to ensure in each column that we only have one piece of information. So for example, don't put first name and surname into the same column if you can avoid it, as this will limit what you can do with the data later on. To ensure that your calculations will work properly, it is critical that you don't mix numerics with text where possible. So don't put text data in columns that you later on may want to perform calculations on. So for example, if you don't know what the sell price is, just leave the cell empty or put a 0. Don't put something like a question mark, as that is going to cause problems later. When it comes to actually structuring your data, you want to organize it so that similar information stays together. For example, you can see here that the address information appears in separate places. From a data entry point of view, this is likely going to cause confusion. So let's move them together. We select the column, move the mouse pointer over the selection frame, then right-click and drag, and then choose Shift-Right and move. There. Beautiful. Now there are a few things we want to avoid when we're working with data sets. Don't put any blank rows or columns inside a single data set. This will cause problems. Also, avoid merging cells at all costs, as this will inevitably become problematic down the track. If you want to center your heading, you can use an option called Center Across a Selection. To do this, select a range of cells in a single row, as we will here at the top, and just as you would when merging cells. Then right-click, select Format Cells, click the Alignment tab, click the horizontal drop-down arrow and select Center Across Selection, and OK. This now looks like the cells are merged, but actually you have maintained each individual cell, but the value in the right-hand cell is now centered across the selection. As we start adding data, we want to make sure that any calculations we create are going to include newly added values. So really good practice with raw data is to put it into a table. We covered the many benefits of working with tables in one of the previous courses, and you'll remember that the major advantage to having a table is that the tables will automatically grow as your data set grows. And we will see why that's so important when we start working with our calculations. So Control-T, make sure you have ticked that your data has headers and OK. If you don't like the formatting particularly, click the drop down so you can clear it altogether, or you can go for something a little bit simpler. I'm just going to go for a slightly simpler one, turn off the band of rows, and importantly, name your table. Now we're going to follow the naming convention of always naming our tables TBL underscore followed by the name. And the reason for this is that whenever we want to perform a lookup in a table, if we preface it with TBL, it makes it easy to find those tables and we're able to distinguish them from other named ranges. When it comes to data entry, we want to make sure our processes are as efficient and reliable as possible. So you might wish to add a drop-down list here on the method to say it is auction or sale, or another drop-down for the type of property. This will help prevent errors and speed up the data entry. Where possible, we also want to save the users from having to type in information they don't need. So for example, a suburb will always belong to the same region, so we shouldn't have to type the region in. We should allow Excel to do this automatically to speed things up and prevent user errors. So what we're going to do here is we're going to select all the data from suburb down to the end of our region, copy that, and we're going to create our first lookup. So I'm going to come to sheet 1, which I'm going to call lookup, and then paste the data. Note that I just pasted the values, so we don't pull the table across. Now, unfortunately, a suburb could fall in different council areas, so we can't automatically look that up. Remember that lookup functions only make sense when there is a one-to-one correspondence between lookup value and return value. This is the kind of assumption you need to be sure of. Now we've double checked this and we are sure that a suburb falls always within a certain region. So here we go, and we get rid of the council. And then we're going to quickly use our Data tab to remove any duplicates. Before we move on, I'm going to name this data. Using named ranges has a number of advantages. Formulas become easier to read and understand when we use named ranges. And once again, as we start changing things, named ranges will give us that responsiveness we're looking for, especially when our data is stored in a table and the named range extends automatically with the table. So we're going to name both of these ranges. Let's select all the data, and then I'm using my Formulas tab to create from selection just the top row, and I'm going to name both of those columns using the heading. So now I have a named range called suburb and a named range called region. And then having done that, I'm going to create another table. And the reason I'm going to do this is so that we have that element of responsiveness in case we need to add a suburb or region in the future. So Control T to create table, OK, and let's quickly name it. TBL_suburbs. Now we have set up everything to create our calculation, which we will do in the next video. But just before we move on to the calculations, let's take a quick look at what our report will look like. So we're going to click here and we're going to just call this report. And once again, we want to go through a bit of a wireframing exercise. You can just use some shapes to get an idea of placement, and then later on, you will replace these with your charts or actual values. So just a quick exercise as we go and grab a few shapes. I'm going to say, well, right at the top, we want to see a heading. And then I need another shape. And then we'll probably have a kind of a chart giving an overview. So this is going to be a chart showing trends. And then a slightly different colored shape over here. We actually are going to have some summary stats, and then maybe underneath we'll have a couple of different charts which maybe show us something a bit different. So it's that simple, but it does mean you start thinking a little bit about what your outputs are going to be and how you're going to lay them out. In the next video, we'll get down to looking at creating those calculations and some of the correct choices to make in the process.